don't think he's gonna bite. There it is.
Oh god, it's just my hair.
So just hold it there.
Wow, it's squirting out. That is all he's got.
The following video follows a group of scientists studying the venom of wild eastern diamondback rattlesnakes from a barrier island population off of the Florida Gulf Coast. All snake handling practices follow strict, approved protocols cleared through the state and affiliated universities, and are performed by experienced individuals for research only. Do not attempt. Alright, I'm going to record you giving us the game plan for today. So what do we expect?
It's about 5 kilometers off the coast. Once we get out there, we are going to hit a tin site first, while it's still cool. See if we can flip a diamondback, which we have done there before. And then after that, we are going to hike the bay side of the island along that shoreline. And that's where I would say probably 60 or 70% of the diamondbacks that I've sampled out of this island have come from, is that shoreline.
They're about to go into the
Yeah, their back
river.
wheels, I think, off the ground. If it's been, Mike, how wet has it been here?
The past couple months it's been super wet, but like this past week has been pretty dry. Yeah.
Hi, my name is Dr. Mark Margers. I'm an assistant professor in the Department of Integrative Biology at University of South Florida in Tampa. And part of my research focuses on predator-prey coevolution between rattlesnakes and what they eat on islands throughout the world. Now, islands have been model study sites in evolutionary biology since the time of Darwin, and it's because they provide these natural experiments that have been set up and run for thousands or sometimes even millions of years. And their isolation often leads to altered species interactions that allow us to study rapid evolution. And that is mostly what my lab works on, is trying to understand how animals rapidly adapt to changing environments. So I've been working on barrier islands in North Florida for nearly a decade now. And I started working on them as a graduate student at Florida State University with my advisor, Dr. Darren Rakita. And my question there really was, do rattlesnakes out on islands have different venom than what we see on mainland snakes? And if they do, how are they different? And are those differences adaptive? Is it related to what they are eating? So to study this, I went out and I collected a bunch of rattlesnakes on various islands and adjacent mainland areas in North Florida. And we did find that the venoms on the islands were very different than the venoms we were seeing on the mainland. So yes, the venoms are different. How are they different? What we found was that it was not different toxins, but rather relative concentrations of the same toxins. So island rattlesnakes did not have island venoms that were not found in mainland snakes. They had the same exact set of toxic proteins, they just made them at different amounts. And lastly, what I was interested in is, are those differences adaptive? Are those differences meaningful? And to test this, we needed to go out and trap what the rattlesnakes were eating and test how well each venom functioned in each rat population. So I collected lots of rats from islands, lots of rat from the mainland, and tested venom function in each. And what we found was that island venom was in fact 3 times more toxic to island rats than it was to mainland rats, and about twice as toxic to island rats than mainland venom was. And the same was true for mainland venoms. So we found that island rattlesnakes, they have different venoms than what we see on the mainland. Those differences are due to different concentrations of the same toxic proteins, but those differences in concentrations allowed them to be locally adapted to their particular prey source.
Great. Hi. Oh. Hi. Sweet. Don't eat venom from him. Nice find.
Made it easy.
All right, Emily's winning.
Yeah, I've seen some will be black to half. Some will be completely tan, almost white like this. On this island, a lot of times they're striped like this. I see that they got sort of a dark head, with some tiger banding, tiger striping behind it. But they're neat snakes out here. They're still, so like further down Short Road on the left-hand side, there used to be like a bunch of crap stored there, kind of like an open field right before the beach.
You want to let him go?
Yeah, put him back.
What do you got? Oh, nice. Probably a racer.
Yeah. Oh, I think you can see pretty well through there.
It was never out. We just heard it rattling. Yeah. Sweet. Good job, guys. Pretty one.
Yeah, this is a much more yellow one.
Are you still recording?
Yeah.
There's the bag. Yeah. That looks like a male. Maybe they're a couple.
Maybe. We'll process this one and
They're all warmed up, that's for sure. Sweet. Good job, guys. Yeah, you're skinny.
They do not like being tubed. They do not like tight things on their heads. But obviously when I milk them, I want the tightest tube possible to prevent movement. So typically what I do is I'll tube them in a larger tube because it's easier to get them in there. They still can't turn around in it, but it's not the tightest. And then I'll replace it. So that way when I back them out, they don't have a lot of wiggle room. So that's what, big tubes in my right hand, smaller tubes in my left. Poke with the left, tube with the right. Yeah, we'll measure her first. I'm pretty sure it's a she.
So the milking technique you are seeing here is what I call the back out method. And it's what I consider to be a safer alternative to the traditional pinning method, both for the handler and for the snake. So in this technique, which should not be tried by anyone who is not a professional, you tube the snake in an appropriately diameter tube that allows the snake to enter but not turn its head from side to side. And in doing so, you have control over the snake. And then you can slowly back the snake out, and you put your pointer finger on the top of the snake's head, your thumb on the left side of its jaw, your middle finger on the right side of its jaw. And that gives you solid control. And what I like about this technique is if at any point you do not feel comfortable with your grip, unlike in pinning, you can just slide the snake back up into the tube and try again. And this is a very safe technique. I've used this technique literally thousands of times with no incidents.
She has, but it's plenty for us. I got her.
Okay, I can let go?
Yep.
Oh yeah, she knows where she is now. So just in case if you were wondering, this snake right here has blue eyes right now because it's really close to shedding. That's right, go home. Hi, my name is Mike Hogan, and I'm a PhD candidate in the biology department at Florida State University. And I'm studying predatory trait evolution and genomics in the eastern diamondback rattlesnake. My particular focus is on the incredible sensory systems that rattlesnakes have. In particular, their sharp eyesight. They actually have eyesight that's comparable to that of your average house cat. They have infrared night vision using two pits on their face, two pit organs. And they also have two ways to smell. They have an olfactory bulb just like we do. And they also have a bidirectional system utilizing their forked tongues and vomeral nasal organ. My actual research has been on the sensory gene repertoire, which allows rattlesnakes to find their prey. With this genetic understanding of sensory perception, I'm able to look at individual genes and look at the coevolution of sensory perception alongside venom and see how these genes are evolving together through the shared selective pressures of predation and detecting your prey and eating your prey and killing your prey.
Corn snake!
You gonna bite me? Wow, look at that.
That's a cool looking one. That does look kind of gray.
Doesn't it?
You're right, actually, now that I take a second look at it, it's
Like,
like
in between the...
Yeah.
Awesome. Don't bite me. Do you want to hold it?
Yeah.
Beautiful. It's pretty common in our field to actually go out and help other researchers with their research, especially if there's overlap. And this is a perfect example of that. Today, I'm out in the field helping Dr. Mark Margers with his research. We're out on an island looking for rattlesnakes. And for this part of the video, you're going to see the crew that I work more closely with at Florida State University. And we're all members of Dr. Darren Rakita's lab. Most of us have a focus on venom. I'm kind of the outlier. I focus on sensory perception, but we all look at genetics and genomics and the expression of these genes and how the genes are involved in the evolution of these organisms. And we all like snakes because snakes are awesome. That's a different one.
I'll take you back, please, guys. Keep him over there. Okay, bag ready.
Can you start lifting the bag up? Yep. Yep. Got it.
Okay, Scott, you got the longer tongue, so why don't you put it down?
Okay.
Did he rattle at you, or?
No, it was moving.
Cool.
Moving, yeah.
It's a pretty one.
Dark. Dark. I thought I was expecting to be lighter here. The other one that you guys got was dark too.
Cool.
So let me take a quick look before we do anything in case there's something else.
Let's get him out of the sun.
Yeah.
Nice work, guys.
We can't take that one though, right?
We're going to get venom and blood from him. I also happen to be the person who put this video together that you're watching because I personally believe that sharing this raw, uninterpretive perspective directly from the scientists is important. I got this camera. I also decided to put the GoPro on this tube so you can see how the breakaway tube works to keep our fingers away from the snake. We're just taking 2 samples, blood and venom, but we're gonna get measurements. Go ahead, bud. So I guess let's do the measurements first.
I was gonna record it on my phone.
Let me know if you need anything, Mike.
Yeah, I'm just working around the GoPros.
120 and a half. 133. So we measure down to the cloaca, the vent, and then we take it all the way to the tip. But we don't count the rattles because they can break off all the time.
Right. Anything to that?
Nothing.
Old man talk.
Just as much as there's already in the soil.
Yeah, yeah.
But now it's fingernail material. It's keratin.
What was it?
I went to poke it in and it just... For every venom sample, we also try to get a blood sample, which could provide us with the DNA for future genetic work. Just like you saw before, we're utilizing snake tubes for this step of the procedure, and this is the safest way possible to get these samples. All right. All right. Are you going to do it, Skylar?
Yeah, that's unless you wanted to. Doesn't matter to me.
Use the tongs.
Yeah, as long as you're not in front of these two. I don't think he's gonna bite. There it is. I personally prefer to use a slightly modified version of Mark's technique to do venom collection. And you can see that we're still using the tube technique. The only difference is these tubes are modified. So there's actually a short section in the very front that separates out. And basically the way it works is the part that you grab has a shorter section that actually breaks away from the main part of the tube. And by having that short section, you have a short amount of the snake inside the tube that you have full control over. And so you can actually put the snake where you need it to be. And there's still about a 6-inch section of the tube where the snake is separated from your hand. So while Mark is very experienced and he's really good at grabbing the snake correctly, and actually Mark is the one who trained me on how to do venom extractions, I developed this technique as kind of a way for less experienced people to learn and to see how the snakes are biting. You lose a little bit of the control with this method. However, your hands are nowhere near the actual head of the snake. So because of that, it makes it a little bit safer. And luckily with the Eastern Diamondback, they have so much venom, we really only need a couple drops for our analyses. So it's not a big deal that a lot of it got missed from the collection vessel. We got more than enough. We were able to pipette a bunch of it off the side of the tube. And ultimately, this was a perfectly usable and effective method of venom collection. So we just wanted to show two methods that are used in our research sphere for collecting venom in a safe and controlled manner.